In problem 19, we're asked if it requires 3.5 gallons of sealer to coat a 840 square foot driveway, how much sealer will be needed to coat a 1,500 square foot driveway? So we'll do this on a separate sheet, and this is a proportion problem. We know that 3.5 gallons of sealer is required to coat 840 square feet of driveway, so that gives us a ratio, gallons of sealer to square feet of driveway. And we want to know how many gallons of sealer will it take for a 1,500 square foot driveway. So I have gallons of sealer to square feet of driveway, gallons of sealer to square feet of driveway. If I solve this, then that will give me the answer. Okay? So I can cross multiply. X times 840 is going to be 840 times X. And that's going to equal 3.5 times 1,500. Well, 3.5 times 1,500 is 5,250. So we have 840x equals 5,250. And we can solve for x by dividing both sides by 840. So x is going to equal 5,250 divided by 840, which is 6.25. So to answer our questions, it's going to take 6.25 gallons of sealer to coat 1,500 square feet of driveway. So there's our answer to number 19. Let's look at number 20. I'm going to do that on this same page. Number 20. Marine biologists captured, tagged, and released 180 penguins. Several months later, of the 55 penguins that are captured, 12 are tagged. Estimate the population of penguins. Okay? So we're going to let x equal the population of penguins. And in problem number 20, we know that originally 180 penguins were tagged out of the entire population. So I have tagged to population. Okay? And then when they came back several months later, they caught 55 penguins and 12 of them were tagged. So 12 of the 55 penguins were tagged. So again, I have tagged penguins to total number of penguins, tagged penguins to total number of penguins. Okay? So if we solve for x, that should give us an estimate for the population. So again, I'm going to cross multiply. So I'm going to have x times 12, which is 12x, equals 180 times 55. Now, 180 times 55 is 9,900. So we have 12x equals 9,900. And if we divide 9,900 by 12, that is 825. So we would estimate that there are 825 penguins in the population. Let's look on to number 21. Number 21, assume that y varies inversely as x. If y equals 14 when x equals 3, we want to know what's the value of y when x equals 18. So we're told in problem 21 that y varies inversely as x. So that means y equals some constant k divided by x. This is what varied inversely means. We also were told that y equals 14 when x equals 3. So if I substitute 14 for y and 3 for x, that gives me this. And so I can use this to figure out what the constant k has to be. So to figure out what k has to be, I can multiply both sides by 3. On the right-hand side, I'm going to get k. On the left-hand side, 3 times 14 is 42. So now I know y equals 42 over x, again, because we just figured out that k has to be 42. And we want to figure out what is y when x equals 18. So y is going to equal 42 divided by 18 because I'm letting x equal 18. And 42 divided by 18 can be reduced. We can divide both 42 and 18 by 6. 42 divided by 6 is 7. 18 divided by 6 is 3. So y has to equal 7/3. Let's look at 22. In problem number 22, assume that d varies jointly as a squared and b, and inversely as c. Let's start by writing that down. We were told that d varies jointly as a squared and b. So d is going to equal some constant k times a squared times b. That's varying jointly. And it varies inversely as c, so c is going to be on the bottom. Okay? So we know we have this form. D equals some constant k times a squared times b divided by c. Now, we also know that d equals 144 when a equals 3, b equals 7, and c equals 14. We want to find the value of d when a is 8, b is 11, c is 16. Okay? So I know that d equals 144 when a equals 3, b equals 7, and c equals 14. So I can use this to figure out what the constant k has to be. So let's clean this up a little bit. 3 squared is 9, and 9 times 7 is 63. So I have k times 63 divided by 14. And I can reduce that. 63 and 14 can both be divided by 7. So I have 144 equals k times 63 divided by 7 would be 9, and 14 divided by 7 would be 2. So 144 equals k times 9 divided by 2. So I can solve, multiply both sides by 2. 2 times 144 is 288. So I have 288 equals k times 9. And then, so if I divide both sides by 9, k is going to equal 32. 288 divided by 9 is 32. So right now I just figured out what k is. I know that d equals 32 times a squared times b divided by c. Now I want to know what's d when a equals 8, b equals 11, and c equals 16. So d is going to equal 32 times 8 squared, because a equals 8, times 11, because b equals 11, and divided by 16, because c equals 16. So 8 squared 64, so I have 32 times 64 times 11 divided by 16. And so if I bring in my calculator and do that work, 32 times 64 times 11 divided by 16, that is 1,408. So D will equal 1,408 if A equals 8, B equals 11, and C equals 16. One problem left. Let's look at number 23 on a new page. So number 23, the length of a beam is directly proportional to its width W and the square of its depth D, and inversely proportional to its length L. How would the strength of the beam change if the width and the length are doubled? So let's take a look at this. We have number 23. We're told that the strength of the beam is directly proportional to its width W and the square of its depth D, and inversely proportional to its length. So if we call the strength S, then that's going to equal some constant K times W times D squared divided by L. Now we're coming up with this because it says the strength is directly proportional to the width and the square of the depth. So we're going to have K times the width times the square of the depth, and that's inversely proportional to the length L. So that's where this is coming from. Okay? Now our question is what if we doubled both the width and the length? What would be the effect on the strength? So in other words, if we had 2W and 2L, then we would have K times 2W times D squared divided by 2L. So we have doubled both the width and the length. And the question is, what would be the effect on the strength? Well, if we take a look at this, K times 2W times D squared over 2L would be 2K times W times D squared over 2L. And the 2's would just divide out, so I have K times W times D squared over L. So the strength would be the same thing if the width and the length were doubled, because the 2's divide out. The strength's going to be the exact same as if they weren't doubled. So the question is, how would the strength of the beam change if the width and length were doubled? And the answer is there would be no change. The strength of the beam would not change at all if the width and the length are doubled. We would still have the exact same strength. That concludes number 23, and that concludes all of the solutions for our review. Good luck on the test.